So you should be on page 8. It says triangle proportionality theorem. This is lesson 4.2 continued. So we broke 4.2 up into 2 pieces, so this is 4.2 continued. The triangle proportionality theorem, that's big words, that just says if one line is parallel to one side of the triangle, so if this line is parallel to this side of the triangle, and it intersects the other two sides, right? So this line DE is intersecting over here and over here. It's not necessarily going through the middle, but it's touching either side. Then it divides the sides into segments of proportional lengths, which means this side is proportional to this side, and this side is proportional to this side. Okay, so we're going to say if DE is parallel to AC, if DE is parallel to AC, then BD is proportional to BE, and so I started on this side over here, so I'm going to say then the next side AD is proportional to EC. They're not equal to, but they're proportional. Okay? So that's going to help us as we're setting up these proportions again. So let's take a look at example 1. We're not going to worry about the converse there. It's not really a big deal. So we're going to go down and look at number 1. It says find the value of x. So we're going to set up our proportions. Again, this whole unit is all about proportions. I'm going to say 12 over 15. Okay, so 12 over 15 equals what, do you think? 14 over x. Okay, so I did the blue sides on the top, the red sides on the bottom. You have to stay consistent, okay? Being consistent is going to be the key here. Now this is an easy problem that we just cross multiply, right? So I can say 12x, 14 times 15 is 210. Divide by 12 and we get x to be what? 17.5. All right? Not much harder than that. Let's look at number 3. Not number 2, but number 3. Go straight down. Number 3. X matches up with this side, but I don't know how much this side is, do I? Do we know how much this blue side is over here? It's 10, right? We do 55. The whole thing is 55. We subtracted 45, which means that this piece here is 10. Okay? So we have x goes with 10. Then we hop back over to the side that x was on. What's the next one going to be, Sharmini? 36 over 45. Good. Let's go ahead and cross multiply. Monique, what'd you get when you cross multiply? We get x to be, did you get x yet?
Yeah.
What? 8. Perfect. Excellent. All right, let's look at number 5. See if you can set it up. Set up your proportion correctly. Braxton, what's your proportion look like? 25 over 30. If you did 30 over 25, it's okay. 25 over 30 equals what? 15 over x plus 7. So it doesn't matter which way you start. It matters that you stay consistent. So even if you have it flipped, you should have 25 times x plus 7 equals 15 times 30. Yes?
Why wouldn't you put 25 and 15?
Why wouldn't you do what?
Why wouldn't you add 25 and 15?
Because we're just talking about this piece here, and then we're talking about this piece here. We're not talking about the whole thing. Okay? So we're talking about proportional parts, which just means just the pieces, right? So just this piece and just this piece, not the whole thing together. Okay? Same thing on the other side, Lexi. We wouldn't add those two together to make x plus 37. We would just take the pieces. Okay? Good question. So 25x plus 175 equals 450. Carla, what are you getting for x?
I'm getting 5.4.
Do you have 25x plus 175 equals 450?
Wait, where'd the 175 come from?
25 times 7.
Oh no, I have a 30 times.
Okay, if you have 30 times the x, then we did something wrong. Okay, so make sure if you did 30 over 25, so you started on the left side, so then that means you go back to the left side. X plus 7 over 15.
Set it up like algebraic equation.
So it should be an algebra proportion.
So it's distributed.
Yes. We get x to be 11. X is 11. Let's try number 6. If you start on the left side on top, then when you go to the next proportion, you need to make sure the left side's on top again.
Do what now?
So like on number 6, if you put, which one do you want to put on top?
It doesn't matter.
Pick one.
6.
6 goes on top and it's going to go over what?
The 3x plus
Nope.
1. No.
Why are you jumping? 6 is here. Look up here. 6 is here. Go straight across.
Oh, why would you do that? Just cut
Because that's the part that it's, they got these parallel lines, cut them off at the same place. See that? So 6 goes with x minus 1.
Okay.
Now you started on 6, which was on this side over here, which means when you do your next fraction, 21 has to go on top again.
Okay.
So you have to stay consistent. We're going to cross multiply. You should have 6 times 3x plus 1.
Yeah.
And you should have 21 times x minus 1. If,
I'm not writing it out right or something.
okay, I'm getting, we said x was 9.
Yes.
Okay, any questions about this lesson? That was that for that one. That was it. Well, there is a homework assignment. But there's only 9 problems on the homework assignment. So if you look at homework 20, number 2 is a decimal, and that's okay. Number 2 is a decimal. On 7, 8, and 9, it says determine whether it's parallel. You're checking to see if they reduce to the same thing. So like look at number 7 down there. 7, let's set up our proportions. 7 goes with what? 10. Okay, so let's write that. So we're on the bottom of page 9. Problem number 7. Okay, 7's going to go with 10. And then 11.2 is supposed to go with what? 16. 11.2 plus 16. What happens when we cross multiply? Let's check what happens when I cross multiply. 7 times 16 is what, someone? 112? Okay, 112. And then what is 10 times 11.2? 112. 112 equals 112, so yes, they are parallel. So when you cross multiply these down at the bottom, if you don't get the same thing, then they are not proportional. If they didn't reduce to the same proportion, then they're not proportional. Okay? So we check to see if when you cross multiply them, if you get the same answer. You do, so they are parallel. The lines are parallel. Okay?